day everyone, so for today's video, we'll tackle about the right triangle trigonometry. The brief history of trigonometry. The Babylonians could measure angles and are believed to have intended the division of the circle into 360 degrees. Euclid, a Greek mathematician who's seen as the original pioneer of trigonometry. Euclid, also known as the father of geometry. First tables of sine or cosine. In the 2nd century BC, a Greek mathematician, Hipparchus, is to have been the first person to produce a table for solving a triangle lengths and angles. The Pythagorean theorem. In a triangle, the square of a hypotenuse is equal to the sum of other two sides, where it is the hypotenuse is equal to the opposite and adjacent. It is named after the Greek mathematician Pythagoras. The formula of the Pythagorean theorem is hypotenuse squared is equal to opposite squared plus adjacent. Let's proceed to the 6th trigonometric function, were later studied by Hipparchus of Nicaea from 180 to 125 BC. Ptolemy Aryabhata 476,550, Varahamera Brahmagupta, Muhammad Ibn Musa, Al-Khwarizmi, Abul Wafa, Omar Khayyam, Bhaskara II, and the others. They are under a 6 trigonometric function in terms of infinite series. Euler's formula as the near modern abbreviations of sine, cos, tan, cot, secant, sec, and cosec, which is sine is sine, cos is cosine, tan is tangent, and cot is cotangent, sec is secant, cosec is cosecant. The right triangle trigonometry definition. All triangles are taken to exist in Euclidean plane, so that the inside angles of each triangle sum to pi radians or 180 degrees. For a right triangle, the two non-right angles are between 0 and pi over 2 radians. So this is example. Sixth trigonometric ratio. So let's use this illustration to answer the following trigonometric ratio. Our sine is equal to opposite over hypotenuse. In a figure, our opposite is equal to A. Then our hypotenuse is equal to C. So our sine A is equal to A over C. Then our cosine of A, cosine is equal to adjacent over hypotenuse, which is our adjacent is equal to B. Then our hypotenuse is equal to C. So our cosine is equal to B over C. Tangent of A is equal to opposite over adjacent, which is opposite is equal to A, then adjacent is equal to B. So our tangent A is equal to A over B. Our secant of A is equal to hypotenuse over adjacent, which is hypotenuse is equal to C and adjacent is equal to B. So our secant A is equal to C over B. Cosecant of A is equal to hypotenuse over opposite, which is the inverse of sine. So our cosecant A is equal to C over A. And cotangent of A, the inverse of tangent, is equal to adjacent over opposite. So our cotangent A is equal to B over A. Let's try to answer the example. Find angle A of the figure on the right side. First, we need to find the hypotenuse using Pythagorean theorem. So our adjacent and opposite is already given, which is our adjacent is equal to 8 and our opposite is equal to 8 and our adjacent is equal to 2. So hypotenuse squared is equal to 8 squared plus 66 squared. 8 times 8 is equal to 64 plus 6 times 6 is equal to 36. 64 plus 36 is equal to 100. So hypotenuse squared is equal to square root of 100 is equal to 10. So our hypotenuse is equal to 10. Now use the definition of the six trigonometric ratios given above to find sine A. So our sine A is equal to side opposite angle A over hypotenuse. So our opposite is equal to 8 and our hypotenuse is equal to 10. So our sine A is equal to 8 over 10. Then the inverse of sine A is equal to 8 over the inverse of sine A 8 over 10 is equal to 53 degree 7 minute 48 seconds and 37. Thank you and God bless. That's all for today.